Hi students, welcome to A&P Science and Pharma. Today we are going to see a practical session of how salicylic acid is synthesized from methyl salicylate. Right? Now, let us draw the structure of methyl salicylate. You know the structure of salicylic acid. It is 2-hydroxy benzoic acid, nothing but salicylic acid. From salicylic acid, if there is a methyl group attached to the benzoic acid, it is called as methyl salicylate. Methyl salicylate. From methyl salicylate, today we are going to see how salicylic acid we are synthesizing. So when methyl salicylate is heated with NaOH, ideally 10% NaOH, okay, this forms a sodium salt of salicylic acid, sodium salt of salicylic acid. So the methyl group here, the esterified methyl group here comes out as a byproduct of methanol. So we will do this in a reflex setup. So all the methanol is reflexed and we can collect it separately. So the remaining product is sodium salicylate. Sodium salicylate. This is not the reaction, complete reaction. There is another step also. So with this reaction, with respect to this reaction is called as saponification. In most practical books, this term will not be there. They will just mention as methyl salicylate reacting with sodium hydroxide will give sodium salicylate by removing the methanol as a byproduct. That is it. There is saponification reaction. You might have seen with the saponification of fatty acids. So when esters are reacted with sodium hydroxide, esters are reacted with sodium hydroxide or potassium hydroxide, the process is called as saponification. This process you will study in third semester organic chemistry, third unit. The saponification, iodine value, acid value, ester value, there this concept comes. So whenever there is ester that is reacting with sodium hydroxide or potassium hydroxide, it forms a sodium or potassium salt. Okay. So this salt when treated with, not treated, when acidified with HCl, acidified with HCl, it forms salicylic acid. It forms salicylic acid. Whenever you are writing in the exam, no matter practical exam or your theory exam, you must write all the structures and the names of the structures also. Okay, you might have seen my previous videos also. There I have stressed it very well. So this is the reaction. So methyl salicylate when treated with sodium, when heated with sodium hydroxide, it will form. When we do the practical experiment, I will explain you clearly what is the color change, what is the cloudiness, what is the precipitate, how the temperature changes with this also. And again, when the salicylic acid is formed, you have to recrystallize this with hot water, because salicylic acid is soluble in hot water. It forms crystals in cold water, ideally ice cold water. Ice cold water. So this is the entire reaction of salicylic acid forming from methyl salicylate. Now we are going to see what is the theoretical yield and what is the percentage yield, practical yield. Now we have condensed this reaction to calculate the practical yield. So what is the molecular weight of methyl salicylate? 152.15. 152.15. What is the weight of salicylic acid? 138.12. So 152.15 grams, that is molecular weight of methyl salicylate, is producing 138.12 grams of salicylic acid. So by this what we are going to find is, whenever it is 152 grams of methyl salicylate will produce 138.12 grams of salicylic acid. In the procedure, we are taking 2 ml 2 ml of methyl salicylate. So you can see methyl salicylate and you can see the numbers here. So methyl salicylate is not a solid, it is liquid. So we are taking 2 ml. You can see here weight per ml. So 1 ml of methyl salicylate contains 1.16 to 1.18 grams. Okay. So based on this understanding, this 2 ml we will take 1 ml contain 1.17 gram. 1.17 gram. So this 2 ml will contain 2 into 1.17 gram. That's it. So this 2 ml of methyl salicylate contains roughly 2.34 grams of methyl salicylate. Now our understanding goes like this: 152.15 gram of methyl salicylate should produce 138.12 grams of salicylic acid. Correct. So 2.34 gram of methyl salicylate should produce how many grams of salicylic acid? That will be our theoretical yield. As per calculation goes, it comes roughly 2.124 gram of salicylic acid. So 2.34 gram of methyl salicylate should produce 2.124 gram of salicylic acid. This is our theoretical yield. In practice, when we are taking 2 ml of methyl salicylate, if you are getting product salicylic acid of 2.14, that means you achieved 100% yield. So if you are getting anything less than this 2.14, let us say 1.8, let us assume you are getting 1.8 grams. Let us assume you are getting 1.8 gram. So now how calculation goes is, when 2.124 gram of salicylic acid is 100% yield, 1.84 gram is how much? Again, it should be 1.8 into 100 divided by 2.124. So as of now we did not proceed for the experiment. So let us assume the practical weight, how much salicylic acid is x gram. So to calculate the practical yield, it will be x into 100 by 2.124. So that is our practical yield. Hope when we proceed for the experiment, we get 100% of the practical yield. That is not practically possible because the chemicals that we use in the lab are at least 95 to 98% analytical grade. So we don't expect to get 100% of practical yield. At least for 90 to 95% yield if we get, that is significantly good and considerable. So now we are going to start the synthesis of salicylic acid from methyl salicylate. So we have done all the calculation part. We have calculated the theoretical yield and the practical yield also. This is the reflex setup. Mantle. Check it is working. Yes, absolutely it is working. So as per procedure, we need to measure methyl salicylate. So you all know it is 10 ml of methyl salicylate. No, 2 ml of methyl salicylate. Just write. Just write. So we have got 2 ml of methyl salicylate. You are pouring into the round bottom flask 2 ml of methyl salicylate, and into this we need to transfer 15 ml of sodium hydroxide. This is 10% sodium hydroxide. Prior to the lab we have prepared it. 10% sodium hydroxide, 10 grams in 100 ml. So you can see clearly this methyl salicylate is insoluble. Methyl salicylate is insoluble in sodium hydroxide. Since we are solubilizing both, refluxing both in the same container, it is not a problem that we can do this. So this is going to be your reflex setup. I am giving the connection to the inlet, water inlet. You can see the condenser level rising and the water also dropping properly. Yes, now I can switch it on. Keep it at 20% so that the boiling point remains at 60 to 70 degrees centigrade. And yes, you can see a white color solid in the RBF, and the reflexing is happening already, heating is happening, and it will eventually get refluxed also. So what is getting refluxed is ideally the methanol. So let us continue it for 20 minutes, and after that you will see total liquid without any solid in that. That means the reaction is completed and sodium salt of salicylic acid is already formed. And since the solution is hot and sodium hydroxide also 10% sodium hydroxide also contains water in that, sodium salt of salicylic acid is completely miscible in that when it is hot. After that we are going to put it in cold water to cool it and then acidify with HCl, and then we can see salicylic acid. Hopefully the experiment will come good. So now you can see the refluxing is happening little faster. So in no time you can see all the methyl salicylate will get miscible in sodium hydroxide and sodium salicylate is formed. And you might wonder how the sodium salicylate, how do you identify the complete formation of sodium salicylate? You will see shortly. As you can see now, as you can see now, the entire methyl salicylate, the whole of the methyl salicylate is solubilized and it is already getting refluxed. The drops are falling, and I can clearly say, since it is not 100 degrees centigrade, so it is not water that is getting refluxed, but it is methanol. As we saw in the theory part, in the reaction, methyl salicylate reacts with sodium hydroxide and forms sodium salicylate and a byproduct of methanol. So the methanol is getting refluxed in the RBF. So let us stop the reaction now by turning off the heat and then let it cool for some time. Not cold, I mean cool. So we can add HCl. We can acidify using HCl for the formation of salicylic acid. Now the solution in the RBF, that is sodium salicylate, is cool. Now we are going to add HCl into this. So you can observe when I add HCl dropwise into this, you will notice some formation of solid. See, there is some reaction, there is formation of solid into that. So dropwise we will add with continuous shaking. That is the cloudy precipitate of salicylic acid. When the complete exhaustion of all the liquid in the RBF is happening, till then we will keep on adding HCl dropwise into this system. You can see I am not rushing, I am just adding dropwise only with continuous shaking. Whenever there is cloudy, see, you can see the cloudy precipitate already forming, cloudy precipitate already forming. So once all the solution is formed into cloudy precipitate, then I will stop it. As you can see now, the solid precipitate that is formed in the RBF, it is not getting solubilized even after shaking also. So we have confirmed the formation of salicylic acid. Now we have to filter this and then I will show you the next step. Now we are going to filter this salicylic acid. So you can see the filtration happening here, and this is how the salicylic acid looks. So this is how salicylic acid looks after filtration. In order to recrystallize this salicylic acid, we have to use a minimum quantity of hot water, and after that cooling enables the formation of rod or needle like crystals of salicylic acid. So we have completed the practical synthesis of salicylic acid from methyl salicylate. After weighing the dry powder, I got 1.96 grams of salicylic acid crystals. So converting that to percentage yield, from this theoretical yield we are supposed to get 2.124, but we got 1.96 gram. Translating that to percentage yield, it goes as 1.96 in this formula. You are replacing x with 1.96 into 100 divided by 2.124. It gives 92.27 percentage. So we are supposed to get 2.124. It translates to 100%. As we got only 1.96 percentage, we got 92.2 percentage. So as we told, we will get expected, we will get somewhere between 90 to 95. We got 92.27. So our experiment was a success, and the synthesis of salicylic acid was successful from methyl salicylate. And there are few important steps that we need to keep in mind while doing this procedure. The byproduct that has come from that is generated from the practical procedure was methanol. As I told you, you must be very careful while inhaling the methanol. You might have to use mask, that is what, because inhaling methanol will result in blindness. Okay, it goes into the eyes, converts it goes into the liver, where it metabolizes and converts into formaldehyde. It will cause blindness. And matter of fact, interesting fact, fun fact for you, whenever you might have seen people having consuming cheap liquor, they go blind and get admitted into hospital. That is because of the methanol. The ethyl alcohol, which is supposed to be present in usual liquors like 30-40%, they will mix with methanol also, and this methanol goes converted into formaldehyde in our liver. That will cause blindness. And one more important thing you must consider while doing experiment, while handling concentric acids like sulfuric acid, always you must be very careful. Use clean glass utensils, clean glass instruments only while using concentrated acids, because the other things, the other plastic or stainless steel or rubber or these kinds will cause corrosion. Okay, so it is suggested always use gloves, preferably gloves, not the normal surgical gloves. You have acid resistance gloves, you can use it also, but that does not give you a freedom that you can mishandle the acids. Always you must be very careful.